Hello, welcome to part 2 of our week 11 discussion. We are going to look at the navigation of application state problem that we introduced last time with that discussion about caches and the fact that the view in the browser versus the state on the backend can get out of sync. We are going to now look at what is needed to make that kind of a thing happen. So here we go. The agenda is understand the navigable app state problem, right? What happens when you want to make the application state visible via URLs? Understand how post redirect get solves the problem at hand, and understand the utility of having get and post requests made to the same URL. You can do this, first of all, which is one new thing, and second of all, that it is useful in solving a particularly tricky issue. There is a different solution to this application, the navigable app state problem, which is used in some applications that rely on JavaScript. They are called single page applications. We will briefly discuss them, but they are not part of this course. Now, don't worry if this section needs more than one review on your part, because right now, up until now, although we have introduced a lot of ideas, each one taken individually is not necessarily that complicated, except perhaps a few things like protocol layering and so on. But this one is genuinely involved, so you may need to review this discussion more than once. It is only because we introduce so many simple ideas together that overall it seems quite a crowded thing, because we are putting together ideas from database courses, ideas from user interface design, ideas from networks, all together in one place. But the discussion about the navigable app state problem is specific to the case of the web, because of the way the browser is a user interface which is separated from the backend, and so it gets a little used to you'll have to get a bit used to it to understand it well. On the other hand, the saving grace is that many of the things that I will show you, you will have experienced on one website or another. So now you will be able to relate some of your experiences about why is it that you cannot press the back button and what happens when the back button is pressed and so forth at a level of a program. Okay, so with that discussion, let's go ahead. Let's define the problem carefully first. The preconditions for this problem are: one is the browser, which is our interface, has a back button, but the back button cannot undo the actions that we did when going forward, such as purchases and so forth. On the other hand, we as users like the freedom to say oops and go back and maybe rethink and do, take an alternative path and so on. And the third precondition of the problem is that the browser and the web server backend can get desynchronized because there may be network events or issues on the machine or what have you. So given these preconditions, how do we implement a smooth user experience? That's the issue. And one solution, as I have mentioned several times, is this post redirect get style. And the second is based on something called history APIs and JavaScript, which you should know about. That solution exists, but we won't touch upon that in this course. Okay, so let's look at some app states we can create. So let's interact with the app. We have visited FairShare DB as it says here. I'm going to now create a new user and watch the maybe I should put it downstairs, dock to bottom. Okay, that will be simpler in this case. So we have get requests, and we visited this page in the first place with a get request. But let me just do that again. So I hit return after selecting this, and I do a get request as expected. All right. Now I'm going to create a new user xyz1 and register them. As expected, the method here is post, right? And the user xyz got registered and we got this data back. So post a new user, and now we have arrived at page 2. The page 2 isn't identified on the URL. However, you can see that there is these 2 pages in the history. Now we are going to create another user xyz2 and do a second post. So we got xyz2 and we have a post here. So we see the current users. All in all, we have several pages here. So if we go back, you will see the old page. Remember, the database is now different. It actually has 2 users, but this page was never updated to that because the page itself resides only on the browser, and so you are just seeing whatever snapshot the browser saw when it requested the page. This is what it means for the reality, which is the database, to get desynchronized from the view. And if you go back still further, of course, there's nothing. This is the first page we had visited. We go forward, we go forward. So the state of the database at this point is the real state, but 2 other states are apparently accessible to us, but they are not really there, right? And this is why, in some sense, it makes sense to cache. It makes sense to disallow caching of the old pages because they are showing you things that aren't true. So this is our visible evidence that there is a desynchronization problem. Now that we have seen our evidence of desynchronization, I'm going to replay the whole thing. So I actually deleted XYZ and XYZ2 from the database, and we are going to do the whole thing all over again. Here, what has happened is I have arrived at this page using a GET request as expected. And because I have deleted all the new users, I can reinsert that user again. And then suppose that I do what we did last time, which is put XYZ2 and hit register, and fair enough, we have XYZ1 and hit it, and we got XYZ1 as the user. So far we have done only 2 things. We have arrived at the page and we have made 1 post this way. But suppose at this point I change the app so that instead of sending a post request that contains some input in the post body, as we know. So let's see what it looks like to remind us of the post body thing. See, if we do this, the post body request looks like this. Instead, suppose that I had a way, we haven't said what way exactly yet, but suppose I had a way to just send a request which gets whatever is in the database at this time, but get it using a GET request. If I did this, the server will return the same database content because GETs don't change the database, and a new page would be available. Let's call it page 2.1, which would look the same as the page on the screen because we have just retrieved the data as it is. On the other hand, because we know that this page was retrieved by a GET and it does not change the database, I could repeatedly make this request again and still see the same thing. So it isn't how you reach a particular state that matters, right? We reached the state of page 2 using a post. But after this point, even if I repeatedly do, page 1 post XYZ1 page 2 get page 2 get right? So get will give you page 2.1, another get will give you page 2.2. But all these pages 2.1, 2.2, etc. will be indistinguishable from page 2 because the way we have written our get function, it's not supposed to change the data set. So in other words, I can repeat this sequence any number of times. And that is our first hint about how you can go around arriving at a form page which you can repeatedly visit without the browser complaining. The trick we are after is if the user sees the same page, whether via a get or via a post, the user doesn't care. It looks the same. But the browser knows the difference. One was visited by a post, and so it will cause a change in the backend if you resubmit it. The other was via a get, and so it doesn't matter what you do. So the solution will be, is there a way to, as far as the user is concerned, achieve the request that the user wants via a get method, right? But do this after we have created page 2 by changing page 1 via a post. What I mean by that convoluted sentence is this kind of a thing. So we took page 1, we changed it with a post, arrived at page 2. But instead of showing page 2, why not show page 2.1 instead to the user? Browser knows there was an intermediate stage called page 2, but the user need not know. And if the user doesn't know, if you revisit that page 2.1, which looks the same as page 2 to the user, then the browser has no reason to warn you because we know that no form resubmission, no data resubmission that changes the content will happen. So the trick is we never show the user page 2 at all. Instead, we only show page 2.1 and we replace in the back button history page 2.1 instead of page 2, but the user cannot tell the difference anyway. And so the browser has no reason to complain if you revisit the page again. That is what the post redirect get pattern achieves. Okay. Redirect is a new kind of interaction which we have not seen yet, right? We have just seen post and get. And the meaning of redirect is, if you are visiting URL U1, then the server tells the browser, instead of coming to location U1, please go to another location U2. And that is implemented as a header called location in the HTTP response. In that case, the browser forgets about U1 and replaces its post or get action by going to U2 instead. That is the purpose of a redirect. Now, from the name, it seems like a redirect should merely change the URL. But oddly enough, a browser can also change the method it uses to visit U2, right? So what it says is, suppose the sequence is visit U1, redirect U2. So visit post U1. That means visit U1 with a post. You get a redirect to U2. But the result of the redirect can be visit get U2. This is unexpected, right? It does make sense for the word redirect to mean go somewhere else. But why go somewhere else and change the method at the same time? It's peculiar because post is supposed to be like a write and get is supposed to be like a read. Then how can you redirect a write to a read? That doesn't make sense. But let's unpack that a little bit. So what we are saying is it's as if a post, which is a write, which is a change to the backend, can instead be seen as a get. Cannot be, right? So what actually happens when you unpack the sequence is something like this. Post changes the content of a URL from content 1 to content 2. Now, what we do is, whether content 2 is available via a different URL or whether it is available via the original URL doesn't matter much in this case. You can in fact send a subsequent GET, and the only content you could receive is C2, because after all this is a database, and if you said you change a particular record, then it goes ahead and changes it. So once you have inserted XYZ1, that's it. Whether it is retrieved by a GET or by some other means like a post, etc., should not matter. And so the strange behavior sort of makes sense, because what you are saying in a redirect from post to GET is something like this: override this URL with the post body that I sent, forget about the old content, and just peacefully return the new content in the place of the old. Once you see it happening in the browser, it will be a little easier to understand, which is why I said you may have to go over this a few times to see what is going on. To solidify our understanding, let's take a look at why redirection was invented. The idea was that, suppose you visit a URL, but the site is undergoing some maintenance. Then you could tell the user temporarily go to some other site where maybe an old copy is available, right? With the warning that, hey, this is an old copy. If you want the latest, come back sometime later. The other is, you used to have a site at a domain D1. You want to move to a domain D2. And so you do what is called a permanent redirect, which says all the URLs that used to come to domain D1 should now go to domain D2. In part, this is because search engines, people try to preserve the ranking of their page in a search engine's rank. And when you do a permanent redirect, the search engine will transfer the ranking of the URL from the old domain to the new one. So domains become very valuable in search once they acquire this ranking because of repeated visits. And so how you distinguish between all these is that you send a request, you get an error code back which says 302 or 307 or 308. In the case of 302, the method changes from post to GET, and these two, 307 and 308, preserve the method. So two things: there is the location header which tells you the new URL, and the return code which tells whether you should change the method or not change the method. As we will see, such a redirect has the effect we want, which is of replacing one URL with another in the history of the page. We start with a post, redirect with a GET, the post is forgotten and the GET is remembered. Let's first look at a demo where we look at the distinction the browser makes between visiting via a GET versus via a post. So we are going to look at our old non-cacheable version. So here what we have is the non-cacheable version, and we visited it with a GET. Of course, that's as expected. We see a GET method here. Now I'm going to register a user XYZ1. By the way, each time I'm doing this, I'm going and cleaning the database so that we can show this behavior again and again. So we first visited FairShare NC with a GET. Now we register a user and do that via a post. This time, remember that the post we look at has a cache control. So it has all these no cache, no store, etc. So attempting to revisit this page, the page we are looking at, is not going to work. But the previous page was retrieved with a GET. so we can go back, right? The browser has no problem whatever in going back. But if we go to the cached page, document is expired. So for an uncached thing, you will have to do a try again, or you'll have to explicitly refresh it. But you can go back and get this particular form, which we retrieved, the get retrieved form, with no fuss. And even if you ask to refresh it, it refreshes it. We can still go ahead and find out that the next page is not visible. The point is that because gets are known to be idempotent, because they can be repeated, the browser is happy to repeat the gets whenever you ask to. We can even shift reload this thing safely, again for the same reason, that nothing is supposed to have changed, so it's always safe to get it again. Okay. What is happening then is, when a user tries to refresh a screen, the browser will ask the user for permission, but not if the form is from a get action, because get is idempotent, so submission is always safe. And this is the basic idea behind PRG. So now that we have seen a demo of how the browser behaves for the two kinds of forms, let us look at some pictorial version of what is going on. This pictorial version is actually from Wikipedia, and you should, feel free to go and read the post redirect page from there after we are done here. This is quite this pattern is well known enough that it has its own Wikipedia page. So let's take a look at what Wikipedia says. Here is the first case. User fills out form, clicks submit, does a post, insert order into the database, and send a confirmation page. This is what we have been doing when we didn't do post redirect yet. But now if you hit refresh, it resubmits the post request. Right? Instead, what we would like to happen is this. User fills out a form, clicks submit, post, insert order into the database. Then it sends what is called a 302 redirect. We will see an example shortly. At this point, the user's machine, remember this one, originates a new request, which is a get. Then you send the confirmation page. You are told your order is successful, and if you refresh it or otherwise request it, you get the same thing back. Okay, so that's really the overall picture. The next question is, what URL should the get ask to retrieve? Because see, here it doesn't say after the 3xx redirect what URL you are supposed to retrieve. It just says redirection to any URL is possible. And we could literally request the same URL using the method get versus the method post. But merely requesting the URL in two different ways is not our only goal, remember. Our other goal is to deal with creation of addressable URLs. We are not trying to solve just the back-end forward problem. We are also trying to make it possible to bookmark or mail a URL to others, and to be able to distinguish between getting the content via a post versus via a get. So here we have the case where, let me do this demo again. In this demo, we have changed a few things. So I have called it fair share URL rather than fair share DB, but the overall flow is still the same as before. So let's begin by visiting fair share URL with a get. Here we have our get method, and we have arrived at the page. So we are following the first trail, get localhost fair share URL, and we have arrived at PG1. Now we are going to post a new user, let's say UVW1, and we will register this user. Oh, I must have registered an already existing user. Let me try something new. LMN1. Okay. Register. And so I have, uh, you know, a page here which shows LMN1 as before. But one difference you will notice, the URL has changed to say to add a new URI or a new URI component called users, and the requests look like this. Here are the requests. First time when we pressed register, we actually did it with a post. And so the post is a familiar thing by now. We have post here, and if you do edit resend, you can see the body. This is the post body, LMN1 and register. Yeah. And now after that, what happened was I got this header. It says the new location should be fairshare_url.users. This is how the browser, the server tells the browser that it should redirect. At that point, the browser automatically issued a GET request, and this GET request looks like a normal GET request. But if you look at the history here, you have only two pages. The post in the middle is missing. And if we go back and if we go forward, you see a GET and you see a LMN1. And the only call that was made was to this, fav icon, which itself was retrieved via a cache. So our history became only two components, even though there were three requests, and we are able to see the same content as before, this LMN1, but via a different URL. And in fact, there's more than that. I can take this, I can take the user's URL. I've taken the user's URL and I have a fresh browser instance, which is different from the one I normally use. I hit this and I can see the same data again. So from two completely different browsers, I am able to retrieve the same data. And this way, the new application state, the one which contains the user LMN1, which is the latest application state, has become visible through a new URL. As it says here, let's kill this. The get localhost pg etc was one possible sequence, and now we have created a new URL, and this URL can be used anywhere. You can send it, you can retrieve it, whatever you want to do. It has enough information via this added users to be able to show us the page with registered users. As recorded in the slide here, the demo showed us that after creating a new user, I think I created a user called LMN1, via get fair share URL, I was able to visit that same page on a different browser via a new URL. And so we can say that PG2 is now addressable with get. That's what addressable URLs mean. How do we apply this to our app as a whole? The answer is as follows. Let's take a look at the code for fair share URL. Here we are. Let's look at this code and compare it with the code for fair share DB. This is the code for fair share URL, and here is the code for fair share DB. What we say here is we first introduce URLs that allow us to get the new page. And this is true not only for the user's URL, right? It's also true for LMN111. If I say expense, you will see the same sequence. There is post, there is get, and there is a expenses URL. And indeed, I can copy it, go to a different browser, hit return, and be able to see the same page here again as we said. Okay, there we are. And so what happened was that we were able to introduce new URLs for each state, even for report, and the same sequence: post, redirect, get, and a new URL. And as usual, there is a location header which says where the post should be redirected to, and a get which gets us this URL. To implement it, what you have to do is this: you have to have URLs like report, users, etc., which generate the same page by getting the same data, but they don't take any input which they are going to apply to the database. And the difference in the code looks like this. Here we have the get method of fair share URL. And if we compare it with the get method of fair share DB, the get method of fair share DB pretty much does nothing. It sets this thing which happens to be unused currently, and then simply calls the post method. Whereas what the get method for fair share URL does is it checks the URI and it looks to see whether the context path, which is the this part of the URL, the last part together. So sorry, the context path is this part and the extension is this report URL, and it checks that the URI is either this or this or this or this, right? Users expenses report. This business of looking at the shape of the URL and transmitting it into different places, whether it is done in the code like this or whether it is done in, for example, methods like web.xml. So you can do this kind of mapping either in an XML file like that, or you can do it directly in the code and behave differently. So the web.xml for fair share URL is not different. So I'll look at fair share URL web in web.xml. Here what it does is you take all these URL patterns / report, users, expenses, and channel them all into the single app. The app itself receives all these things and starts analyzing it. In production code, there are different reasons to put this routing in different places, but for our app, for sure, we can rely on simple routing methods as shown in the code. And here what we are doing is, if it's either the none URL or the users URL or the expenses URL, etc., what we do is, if it is users, then we get all registered users. If it is expenses, all expenses. If it is, expense report, etc., etc. And we are returning actually the same JSP filled in the same way with the same data, but no content in the input field. In some cases, you can give pre-filled input fields, etc. For our application, we don't need it, so we haven't done that. Let's take a look at the difference between the post methods in these two cases. So here is post from fair share URL. and here is post from Fairshare DB. As before, we analyze buttons. The analysis of the buttons is no different in the two cases. This code has some cache control stuff, but it doesn't really matter at the moment, so we'll ignore that. Just focus on the part that matters. In fact, I will, for the purpose of this comparison, I'll just delete it so it's doesn't clutter the comparison. There we are. So here we go. And so try, connect, etc., etc. The distinction is that in the case of Fairshare DB, we had no gets, there were just posts. So we just register the user and get all registered users. Instead, here we do something different. We say register the user, and if you are successful, then you send the redirect. Now, we are not directly calling all registered users or anything from the post in the success case. In the success case, we go back to the browser. The browser sends the request to the app we are looking at again, and then it is processed as a GET request, right? One question is, why not do it in the browser and save the round trip? Well, we can analyze this further, but for now, let's just say that for whatever reason the protocol has turned out this way historically, that doing it via two requests like this makes more sense compared to the other alternatives. What has happened though is that the post is completed and its result is thrown away in the browser. That's why there is no point in getting all the data even if you had it the way things stand. You could have designed a different protocol other than HTTP in which we could have saved the round trip, but that's the protocol that we have. Therefore, in this protocol, all the post does is change the database, send the redirect, and then the effect of the post is retrieved via GET. So this is important. The effect of the post is retrieved via GET. Important part, effect of post is retrieved via GET. That's the flow that we have done, which gives you smoothness in the browser interaction. What should we do in the failure case? Now, in the failure case, in our app, what we have done is follow the old way. That is, just show the error, right? And show the data. And the reason we can do it like this is because even if we have duplicate submits because of user behavior, nothing will change. We will still get our database won't be harmed in any case. So let's see what that looks like. So I'm going to try to register a user here like this, LMN1, and as expected, I see this button here, and we haven't done a redirect. This is just a straightforward post. Now, if you put in a proper registration, then the next request has a post get with the post getting forgotten. So as far as the history is concerned, there were these two URLs, one of which had failed. And if you try to go back to that URL, you are simply able to go back. Because even if you submit something, nothing will go wrong, right? At least that's the design of this app. Actually, the thing is that let us see what happens if we hit expense. If we hit expense, we get an exception, because the way we have done that, the validation job is incomplete in our toy application, where two things were expected, only one thing happened. And so we are okay that our database itself doesn't actually change. So oddly enough, in this app, this kind of half-hearted thing where we get these failures is tolerable. But that's a very unusual case, right? In a real app, these cases will not make any sense. In a real app, we would do something about going back. We might say that, for example, we might turn these buttons unsubmittable, or have a warning that says you are looking at an older state, or what have you. Whatever makes sense for the business logic of your application. That's what matters. And the pattern here, that is redirect in the case of success and return as usual in the previous case, you could do it differently. You could send these cache invalidation headers, right? And then the page won't show up. It will just show up as can't be resubmitted. That's okay too. It's again up to you for your particular app what you do. And thus we have created shareable URLs, and we have taken care of application state sharing. So a summary of our demo is that for our pages we have URLs, users, expenses report. In the implementation we have get methods which show just the form and retrieve the data. Post methods make changes, deal with the failure case, and in the success case redirect. There are a few edge cases. One which we looked at is what to do if there is an error. If it's an e-commerce cart, you will actually, it's useful to preserve the error, let the user go back and change it. For that, we cannot rely on the locally cached form. We actually have to make sure that the form with the error is stored in the database and retrieved from there. So we might make the form uncacheable even with a post redirect get in spite of errors, such that when the browser goes back, it can retrieve it from the database. This is because the e-commerce vendor needs you more than you need them, right? You could always go to some other vendor. But a bank will force you to relog in. It's sometimes for the case of security, at other times because you need the bank more than they need you. One other failure case which we didn't look at is the case where in this redirect, the post goes through successfully, but it is actually the get which fails. If that happens, we are now stuck in a strange state, and we would consider it reasonably rare. So we'll have to figure out how to deal with that. For example, we may have a rare case of a non-resubmittable stuck state in which you tried the get, but the get didn't work, and so you encounter an ordinary browser failure of being unable to retrieve a page, in which case you can let the user submit again actually. So not non-resubmittable, that's a typo. We have a rare case of a resubmittable form, which because it is retrieved by get, can be refetched. So that's the overall flow of post redirect get. Okay. One last thing before we are done with this session, just a few words about a different solution for this state synchronization problem, or the application state problem. This navigable app state problem, in cases where the new app state gives you a completely fresh page, you use the post redirect get pattern. But many recent web apps instead use partial page updates. So instead of changing the whole page when you have changed, say, suppose you add a new user, then you just want to add, in this case, if I add a new user LMN, my entire page shouldn't change. I should just add a new row over here. That would actually be ideal from efficiency and responsiveness perspective. So you can do partial page updates and directly change the DOM. DOM is this one, right? You remember from before, which is the document tree. So you can directly edit the document tree using JavaScript and insert just one row by fetching the content from the database. So such an app, if the app synthesizes a page in this fashion, then in order to make such addressable URLs and their behavior look the same as a full page refresh, they can also synthesize the URL and the history. And in fact, such a history API is actually available in JavaScript these days. So the user gets something like a full page behavior, but at much greater speed. And such apps will be called single page apps. But as far as the user experience is concerned, they will try to preserve as much of this addressability as they is necessary for their application. Okay, so with that we have done one of the more perhaps the trickiest part of the new kind of design that the web requires. And our next session we will add cookies and sessions and talk about one thing which we haven't seen before is form resubmission by using a resubmit token, separating users using cookies and so forth. So first we will deal with separating the users using cookies and then go on to the form resubmission issue.